So this is the Matlab video. Right here is the Matlab icon and VCL, and if you click on it, you will find that it takes a lot longer than you think it should. And so I'm going to go ahead and record this. You can skip ahead if you want. I don't know how long it's going to take, but we're going to watch this little box come up. And then we're going to have to wait until this word in the far left corner says ready, because it'll say busy or initializing. We have to wait forever. And I want to make sure I show you down here. It says initializing down here, and it will say busy until it finally starts. So the problem is this cursor is blinking and you think it's ready, but it's not. So if you try to type stuff, you'll see it on the screen, but it's not ready yet. Sometimes I get tired of waiting and close down Matlab and restart it. And it's probably, it doesn't help anything. But it seems to speed it up, even though it probably doesn't. Right, so I thought there was some value to you in seeing how long this takes on the VCL. Okay, so if you get really sick of this, you can just close this down and restart it. I don't know if I'm going to give up or not. You know what? I think I give up. I'm just going to close it down. It doesn't want to stop. Alright, I'm just going to try it again. There's probably actually no value in closing it down and starting it up again, but I'm just kind of superstitious. It seems to work better the second time I start it. Still waiting. Come on, Matlab. Anyway, so once it comes up, this is the command window. And this is the workspace. There's the current folder. This just gives you your files and directories and stuff. This tells you your variable names. It's taking even longer than I expected. This is seriously annoying. It's like, should we play Tetris or something while we're waiting? It's still initializing. See, I can hit enter, or I can hit numbers and nothing happens. It still says busy. It's still initializing. Okay, finally it's waking up. So this warning has nothing to do with the fact that I was just poking at it. It still does that, even if I'm very patient. Okay, now we have, now you know something about Matlab. If you just type in a calculation like 7 squared, yeah, okay, 7 squared, it automatically goes to the variable name answer, or ANS. So you can do things like square root of ANS. Very exciting. Okay. So what we're going to do is we're going to, first of all, we're not going to create an M file, which is a Matlab script file, but let me just show you here. You could say new script, and then there's an editor, and you just type it, and you can save it as a .m, like the extension is .m, and then you can execute it with the run button. So this is just like every other environment that you know and love at this point. You know that you can save off your code and run it again. Okay. But there's nothing to hand in for this lab, so I'm not going to worry about that. But if you wanted to, that's how you would save your commands. Okay, so first I'm going to have you read in the data from the file that we've been using. Here, Matlab is a little pickier about whether you use single or double quotes. Sometimes it cares, sometimes it doesn't. So to be safe, I'm just going to use single quotes. If you use Octave, which is a free version of MATLAB, some of the commands are slightly different. And so if you're doing this on MATLAB instead of on, if you're doing it on Octave instead of on MATLAB, and some command doesn't behave the way it does in the video, then you should just look it up online to figure out what the conversion is. But most of them are identical. This little symbol, this semicolon here, is important in MATLAB because it means I don't want to see the results. That's what it means in MATLAB. It's a different meaning than in the C family of languages, which means end of the command. But if I just said A equals 8, it will echo it back to me. But if I say A equals 8 semicolon, it means suppress output. That's what it means. Okay. So the annoying part is you can see this on the screen, there's all my data. So the problem is it's kind of a gobbledygook mess. It's a single string. And also notice there's a return here, and there's actually basically an empty character here that you can't see. So it's kind of a mess. So I'm going to try to split it up. And what I'm going to use is this command called string split. And I want to split it by more than one thing. If there is a space, I don't want to see it. If there is a comma, I want to split on the comma. And if there is a return, I want to split on that. So here's my curly brackets defining my set of all the things I want to split on. Now I want to see the size of the thing I just created, as opposed to the size of S. Okay, so the size of S is just telling you how many characters long it is. That's a lot of characters, 47,187 characters. But now that I've split, so you see I've split at the end of each line, I've split on the commas, and notice this is not divisible by anything nice, because we have one extra character here. But if you count this up, there are 20 columns in our data. And so I'm going to actually be able to resize this, and since the number of columns is 20, I'm just going to call that K, so you can see what's going on. My data is going to be a reshape of S3, but I only want to use 1 through 10080 because otherwise I'm going to get this last character that I want to ditch. So I have to be really, really picky about this. I got to get rid of that extra character. And this is how I'm telling it to, like, all this punctuation is really meaningful. So the 20 means every 20 things I want to start a new row. And this bracket just means keep going till you get to the end of the data. And this is telling me that I want to transpose a matrix. Let me explain how this works in MATLAB. So in MATLAB I could have a matrix that looks like 1, 2, 3, 4, 5, 6. That's what my matrix looks like. But what does M prime look like? If I just put an apostrophe thing, that means I want to flip that matrix over. It's a very cool MATLAB trick. If you like to do matrix multiplication or flipping it around, or you want to solve any kind of linear algebra, MATLAB is your tool. MATLAB is your go-to tool. But that's not what we're here to talk about today, so I don't want to dwell on that, but I just wanted to show you what this little symbol meant. And the dot I'm not going to really talk about, but you need that there. Okay? So what is the size of my data? So that's what we wanted. We want to see what my data looks like. It's actually what we wanted. It's hard to see this. The formatting on the screen is kind of bad. Okay, but it did pretty much what we wanted it to. Okay, so what about the curly brackets mean that it's a cell array that we're looking at, and it's a little different than other data types you're used to. But if I just say my data 1, colon, it's just going to tell me all my headers. Those are all my row headers that I had before. Okay, so that's just to reassure us that those are there. I want to create a matrix that's full of my data, but I'm going to pre-fill it with zeros, and it's going to match the size of my data because that's the easiest thing for me to do. Now I apologize because we don't have access to a nice package that'll do these kind of things for us, so we're going to have to type out a little bit of code by ourselves. But before we do this, I want to explain what it is we're doing. I'm going to turn all my string values, because I read everything in as a comma separated value. It's a text file, everything's strings, and so I have to turn all my strings to numerical types, and stir to num does that for me. And there's also something called NaN, which means not a number. It's common across lots of platforms, almost every platform. It's actually an IEEE standard. It's not just a Matlab convention. So NaN means not a number. And what happens if you type string to num on something that isn't numerical? It's there you go. It's very boring. But I also want to just save the size of my data so I don't have to keep saying size of my data. That way if I do size 1, sorry, wrong punctuation, size 1, size 2, then I can just access that. And so what we have is 504, actually really 503 observations across 20 columns. So we're going to try to turn this into a matrix, and so we have to type a little bit of code. So we're going to do a nested loop for I is 1, 2, and size 1 is 504. And we're going to say for J, the indentation does not matter, but I'm doing it for readability. Okay. This kind of thing would probably be better to just put in an M file and just execute it, but it doesn't matter. It's not that big. So I'm going to take every element from my cell array, and if it's possible, I'm going to convert it using string to num. Okay, so if I'm able to do this, I'm missing a piece of punctuation. There we go. I need another one actually. There we go. If this is correct, if this is true, if this is a non-empty cell that it creates, I want to do the conversion. I'm going to go ahead and do the conversion. Okay, but if not, I'm going to just fill it with something else. And in Matlab, the best thing to use would be not a number. There we go. Now in Matlab I have to end my if. There, I'm ending my if. I'm ending my J for loop, and I'm ending my I for loop, and then I just have to wait a few seconds, and I typed something in wrong. So I'm very, very sorry about that. I'm going to just go back up and fix that. I'm hitting the up arrow key. I'm going to hit the arrow key, string to num. I forgot the num. Whoops. And then 3 ends. Hopefully this will work. It just took a couple seconds. Okay. That was the hard part. That painful part is over. Again, if we had a package, we wouldn't be doing any of that. So anyway, just once you have to type in that crazy code. All right. Now what is sitting at my data 120? That is the word exposure, and that is to remind you that in the very last column we have exposure. So what I'm going to do is I'm going to actually create a variable name called exposure, and it's going to be from 2 to the end because I don't want the word exposure in there. And so it's going to take columns 2 through the end, sorry, rows 2 through the end, column 20. And that's going to be stored in the word exposure, the variable name exposure. So this is just to remind you, what is the very first category? It's the gender, it's the male. If it's a 1, it's a male. If it's a 0, it's female. So I'm going to create a variable name named male, and I'm going to fill in, I'm going to just grab that column. I'm just extracting that column right out of MD. MD is just my data, but I already used the word my data. Okay, and what else do I want? Oh, I want the temperature, the current temperature. And I happen to know that's in column 14, so I go ahead and take that. I forgot to hit the semicolon, so I got to see all my data. Oh well, no big deal. Okay, so now I can start plotting stuff. So that was painful, but it's done. And if we really were using this, we could easily just put that in a script file and run it each time. We wouldn't have to type it over and over again. Okay, so it's not that bad. And now I'm just going to plot temperature against exposure, and it looks the same way it's always looked. We're not very shocked. Okay, so we're going to go ahead and split it by gender. So I'm going to just get rid of that plot and do the plot that we usually do. Here's how you do mean, median, and because this is a real computing system, we can do mode here. This is for whatever reason, not like R where mode doesn't exist. Standard deviation, all the stuff that you're used to. What did I say? Median exposure, did I do that? Then that's the same as saying quantile of exposure and then saying 0.5. But once you invoke the quantile command, you could change it. Whoa, I meant to do this. And then you could just have any quantile you want, but you could also just put it anywhere you want. Okay, so you can just find any of those cutoffs. Now I'm going to do this cute thing. It's going to seem very R-like. I'm going to split off the males and the females, but it's using this clever little logical trick. It's saying, I'm sorry, I forgot to put the semicolon. All the current temperatures that occur when male is equal to 1 are going to go into a new variable name, and all the exposures analogously. But I meant, yeah, male is 1, that's right. Now I'm going to do the same thing for females. Okay, so what are the sizes of these things? You can look over here. So CF, there's 299 females and 204 males. And that's consistent whether we're doing the current temperature or the exposure. If those numbers aren't the same, then you typed something in wrong. So last time I did this, I think I typed something in wrong, and I'm like, hey, I made a mistake, because obviously the size of CF has to match the size of exposure F, because I'm just grabbing a column and I'm sorting out by whether the male, the analogous male is 0 or 1. So anyway, I've got my groups now. And then from here on, okay, we've done all the hard work, then the rest of this stuff is easy. So it seems like in every environment, you win some, you lose some. Some stuff is really, really easy, some stuff is really hard. Okay, so in Matlab, if you don't tell it hold on, it's going to give you a new plot each time. So I said hold on so that I can do the next plot. Oh, I didn't tell you what boo means. Okay, it means, it was blue circles, and now I want red circles. So I say R, and this is the lowercase o, and it just means make little circles. So BO MO means make little blue circles, and RO means make little red circles. So there we go, little red circles, little blue circles. Maybe we want some lines. Okay, so we want male line is polyfit. So you can fit any size polynomial you want, and I'm only fitting a line, but you can fit any order polynomial. You can fit parabolas, whatever you want. Okay, but I'm going to make a female line, and I'm just going to change these guys here from M to F. There we go. All right, then we're going to put those on the graph. So we're going to do this. We're going to say, oh, before I do that, I just want to show you min for the males and females is the same, and max for males and females for the temperature, because I measured them on the same days. So the temperatures for the observations ranged from 40 to 78, but I'm just going to say 40 to 80. I'm going to plot these guys from 40 to 80. So I'm going to plot from 40 to 80, that's on the x-axis, polyval. So I'm going to evaluate the polynomial that I just created that is called male line, and I'm going to calculate it from 40 to 80. You know, because it's a straight line, I only need to calculate 2 points. If this were a parabola, you'd need to actually create a whole series of points, but I'm being lazy because this is telling me I want to plot from 40 to 80. This is telling me I'm only plotting a point at 40 and 80, and I'm connecting the dots. And so if I wanted to, I could have made more points in here, but it's just a line, so 2 points determine a line, so we're good to go. And we're going to do the same thing in red for the ladies. And then hopefully I didn't lie to you, and I've got my red and blue lines. Okay? Again, if you had a parabola that you wanted to fit, you'd have to put more fit points in here, and you could do something like, you could do something like V equals 40 by 0.1 to 80. I'm just going to show you how many points you'd get. You'd get a whole bunch of points, and then it would be a beautiful plot. For a line, you don't have to be picky about that. Okay, I still have my hold on, so I'm going to put a title, fit lines for current, temp versus exposure, and I can do Y label is percent body exposure, and X label is temperature in Fahrenheit, and legend can be males, females. So this is something neat about Matlab. Okay, so let me show you how this works. Where is northwest? This is telling you that you want the legend at northwest. You could also tell it a point, I believe. I'm not sure how, but I think you can do anything like that in Matlab. I think you can just say exactly where you want the legend. But the most common things is when you're looking at a plot, you usually want the legend north, south, east, west, northwest, southwest, whatever. So you think about it as if it's on a compass. There's a compass rose sitting here, and it tells you where you want your legend. I don't know why they don't say upper left. They say northwest, but that's a Matlab thing, so whatever. So that's how you put the legend where you want it. And so I guess that's all you need to know about plots for now. That you've got the basics here. Okay, so next you want to know things like correlation between like temperature and exposure. Very easy here. Histogram, beautiful histogram. Well, it's hiding. Whoa, my bad, because I had hold on. So let me just do the histogram again. There we go. So what else do we want? Box plot. I did not recode my variables. I don't think there's a way to do that in Matlab, so I just used the male variable of 0 and 1. Okay, you can do mean male to say, hey, we have 40%, 41% males. What else do we have? I guess just to finish off, I'm going to generate some random data. Random data from 1 to 100. What does that look like? You have 100 values that were randomly generated. Okay? So I'm going to plot, and this was really, really hard on other systems, but it's trivial on Matlab, and that is a beautiful thing. Okay? Cumulative distribution function for Matlab is just cum sum. That's it. Very easy, and then you just plot it. Super, super easy. Okay, so every system has its pluses and minuses. Matlab has a lot of pluses. Well, I'm just going to generate some random data for you. I'm going to generate a whole bunch. Dot star means element by element. I want you to do the following. So when I just created this right here, it's a vector with 10,000 elements in it. So each of those elements is going to be multiplied one by one. Each one is going to be multiplied by 15, and then 10 is going to be added to it. And I forgot to hit the semicolon, my bad. Okay, but the whole point is I wanted to make a histogram of it. And so I can show you the histogram. And see, because it's got 10,000 elements in it, it's much better than the one I just did before, which only had 100 elements in it. Okay? If for some reason you wanted to save, you know, something, you could say like CSV write, hi, CSV, and I want to save MD, for example. Then we could come out here and see that, well, I guess it didn't save it there. It probably did, I just don't know where hi CSV went. It apparently did not go to the desktop. So wherever the default directory is for writing, aha, I don't know where it is, but here it is. Show in Explorer. Now that will tell me where it is, if we're lucky. So it's hidden inside my documents inside a Matlab folder, and it's a Microsoft Excel document, I guess, or a CSV document. Let's see if we can find it. So I got to go to my documents. Aha, I found it. And I can crack that thing open and look at it. So anyway, if you generate something from inside Matlab, you can export it, and there you go. How exciting. That's the same data we've been looking at, but see, this one's exposure, male. So we lost all of our string data, but we have all of our numerical data. Gee, where have we seen that before? We've seen that before in Meta, inside Stata, where we go over to the Meta side and we lose all of our string data, but then when we go back to Stata, we get it all back again. So anyway, that's all you need to know for my little demo on Matlab. And hopefully you enjoyed that.